Finding the maximum and minimum values of y. Find the max and min values of y and the value of x that will give you those maximum and minimum values. Now, you know that the maximum cosine can be is 1. The minimum is -1. Same thing for sine. Right? Max and min are 1 and -1. So unless you have something weird where you have like an absolute value or cosine squared that's going to change those negatives to positive, then your maximum and minimum values are always going to occur when you have cosine or sine being 1 or -1. So I know that then this cosine of all of that is going to have its maximum to be, or minimum to be 1. The cosine of this would be, for maximum, that would be 1. And then I'm also going to have over here 10 plus 7 times -1. Now I'm going to apply that, I get 17. This will be 3. All right, so this is my maximum, and this is my minimum. And you may think, you know, like, why did I do that problem that way? And I think you're going to see why on the next problem on why I did it that way. So I just need to figure out when am I going to get my maximum and minimum? So here, I really want to know when is cosine theta equal to 1? That's my first question. When is cosine equal to 1? Well, I can look on this. That's the easiest way to do it, really, cosine of 0. Or you could use your unit circle, where cosine is your x-coordinate. So that would be when theta would be equal to 0. Well, I really am not using theta. I'm using 3x minus pi over 4. So I want to know, when does 3x minus pi over 4 equal to 0? So I just have this equation I need to solve. So when 3x equals pi over 4, or when x equals pi over 12, that will give me my maximum. And then the next problem, here I want to know, when is cosine theta equal to -1? So again, the easiest way to do that is to use this table. Cosine is -1 at pi, 180 degrees. So theta would equal pi. But remember, I don't have theta, I have 3x minus pi over 4. When does that equal pi? So there's a couple different ways to do this. I'm just going to add the pi over 4 to both sides and then divide by 3. It'll be 5 pi over 4, divide by 3. That will give me 5 pi over 12. So those are my maximum and minimum values for that equation. Any questions with that? Okay, so here, again, I'm looking for max and min. So here I have 14 minus, the most cosine can be is 1. And the least cosine can be is -1. But look what happens when I evaluate these expressions. Because there's a negative up front here, a subtraction, I actually have my maximum at -1, and my minimum value is at +1. Right? So this is my minimum value, and this is my maximum value. So now you can see like why I plugged in 1 and -1 before I labeled them max and min. Any questions so far with that? Okay. I want y'all to try to work through the rest of this and see what answers you get there. Try and do that on your own. Okay, I want us to look at solving these equations in a couple of different ways, just because I want to remind you that there is more than one way to solve an equation, and you might have a particular method that you like. If you had this type of equation in transition math, and you didn't have a pi in there, like if it was 2/3, then you were taught to just multiply by the reciprocal of 3/2. Well, there's nothing wrong with pi being in there. We can still do that. I can multiply by my reciprocal, 6/pi. So on the left-hand side, the pi's and 6's cancel, you get x. Over here, the pi's cancel, and you have 6/4, which simplifies to 3/2. Right. So multiplying by the reciprocal works on this problem when you just have one term on each side. If you have more than one term, I can do this problem a couple of different ways. I can add pi/4 to both sides like I did up here. I added pi to 1/4 pi. And if you were doing that on the calculator, you're going to think of this instead of pi plus pi/4, you're going to think of it as just 1 plus 1/4 and put that in your calculator and then stick the pi on the end of it, right? When you get done with putting that into your calculator. But another way to do that problem is to get rid of your fractions by multiplying through by your least common denominator. In this case, least common denominator is 12. So if I multiplied everything by 12, I would have 2 pi x minus 3 pi equals 12 pi. So that's 2 pi x equals 15 pi. Forgot my x. I'm going to divide by pi. So I have 2x equals 15. So x equals 15/2. Guys, once you get this equation, then it's just algebra from here on out, just basic algebra. And a lot of what our main lesson is supposed to be today, which we haven't got to yet, is still just using algebra. Okay. Problem 3 is going to be the same type of thing with sign, right? Maximum and minimum are at 1 and -1. And I would put 1 and -1 in and solve or simplify my expression before I really figured out which one's the max and which one's the min. So I have -5 times 1 minus 20. And I have -5 times -1 minus 20. That's -15. And that is -25. So my minimum is actually when sign is 1. And my maximum is when sign is at -1. And we're not going to have anything weird like what I was talking about earlier, anything that would turn those negatives into positives, like an absolute value or a squared. But if I did have something like that, then's when 0 would come into play. Right? So the biggest sign could be would be 1, and then the smallest sign would be 0. But we're not having to worry about that in this lesson. So the question here is, when is sine theta equal to 1? And over here, when is sine theta equal to -1? So again, you can use your unit circle on that, or you can use your handout that has your table of values for your 30, 60, and 45, but then also the quadrantal angles as well. All right, so sine is 1 at pi over 2, and it's -1 at 3 pi over 2. So this would be when theta equals pi over 2, and this would be when theta would equal 3 pi over 2. And then from there, you would solve. And we're not going to take the time to solve the equations. Let me give you the answers, though, so you can go back and finish working out on your own if you want to. Over here, x would be pi over 4. When you solve this, you get 7 pi over 12. So I've set up most of that equation for you, and you can go back and solve that on your own.
All right, in this next problem, we can see how trig functions can be used in real-world situations. Problem number 4, the average monthly temperature Y in degrees Fahrenheit for a city can be modeled by the equation given where X is the month of the year. What is the highest average monthly temperature? In which months does this occur? And then graph the function. As in my previous problems, I know that the maximum sine theta can be is 1. The minimum sine theta can be is -1. So my function value is either going to have a maximum when sine theta is 1 or -1. And in this case, I'm adding 14 sine and 33. So I've got all positives there. So I know my maximum is going to be at 1. So plugging 1 in place of sine theta, I have 47 degrees. So I want to know, when does this maximum temperature occur? Remember that the 1 is not equal to x. It's equal to sine of this expression that's in parentheses. So I want to know, when does sine theta equal 1? And you can look on your unit circle or your table of values to figure that out. Theta would be pi over 2. I'm not really interested in theta. I want to know when x is going to give me my maximum. Okay, the part of the equation that I have highlighted pink, I have substituted in place of theta. So I need to solve this equation. And I get x to be 7. And the 7th month is July, so that's when my maximum temperature occurs. The last part of this question asks you to choose a graph. It's going to be a multiple choice part, so just be sure that your maximum is occurring in the 7th month, which is July. One other thing I want to point out about the graphs is that you will notice that your graphs are going to have a period of 12 months, and that makes sense because you've got 12 months in a year, and then your graph's going to start repeating again.